Hello to everyone, and this is schematics diagram of step down DC to DC step down converter. Here we have a halogen bulb, and I tap just for. Here we have a halogen bulb to just show you a constant voltage is power. Okay. And after that, I was done this project 2.5 years ago, and after that, when I done, after that I threw in the scrap, and I have condition of this like this. Okay, so I need to set a little here to show this big old project. It's okay, and you can adjust the voltages. This is the input voltages. Okay, I am decreasing, but the output is constant. Okay, now we can adjust just for 15 volts because we have no any constant power supply for this PWM modulator, and this is the UC3843. You can just make with this little schematics. Okay, you need to have one UC3843 and some 2 or 3 resistors, and if you need to, you can adjust the frequency of this PWM modulator. So you need to hear one potentiometer of 10 kilo ohm, and here you need to have inductor depending on your power consumption and your amps, and here you need to have some capacitor. Okay, and for output voltages you can adjust from this potentiometer. I am adjusting. You can increase and decrease the voltages. Okay, and you can get constant voltages. Now here we have a 14.7 voltages input, and here we have output 6.027. Now I am decreasing the input voltages. Okay, as you can see, the output is constant, but here we have no fixed power supply to operate this PWM modulator, and we can step down from 100 and 150 volts, but we need to assemble again this, and we need to work again to make a powerful step down converter, and after the step down we need to work on step up powerful converters. Okay, and I was make a powerful boost converter. I'm showing you. And for boost converter or step up converter, I was design a proper PCB, and after that I was threw in the scrap. Okay, because I was just done. After that I need to throw. Okay, but now I need to create these projects again for my YouTube channel. Okay, here you can adjust the output voltages. You can decrease this. I need to decrease. I think 4.2. the decreasing point, last, no, 4.6 volt, the decreasing point, and we can increase how much. Here we have a 99% duty cycle PWM modulator, so I need to check. You can adjust, okay. And the output voltage is also constant, but I have a variable bench power supply, so now I need to increase, and as you can see here we have a constant voltages, okay. And you can decrease again with potentiometer like this, okay. Oh man, we have a call and I think I does a mistake. Hello जी, आओ जी, सही था, बस 5 मिनट वाया उधर गए फिर 1700 हाँ इनकी किन्ने की जो मुरम्मत कर रही थी बस दुकानदारी ने था ना तैयार से सड़े वाली वर की जो गुजारा को मुरम्मत कर रहे थे घड़ो अच्छे नहीं की जो बकी और रुपए बकी नहीं की सुद्धा खराब शेयर होता खराब शेयर होता सस्ता मसले दो जी हाँ ना सुद्धा खराब शेयर ना Wait, I have a call and I am live, okay. I am not ending this live. I was just a mistake and I am telling you. Wait. चिक्का मदर था
रुपया को दरकार लेते नहीं
ना रुपये नहीं दे रहा
50 रुपये वाला 100 रुपये
1700
रुपये
Picture.
Ready? Record कर लूँ क्या?
Kita shutter dah tele berarti ini orang.
ज़रा मजबूत होते
Biar dari mati urara sermat ka. Sudah gua orang nada.
चिकन दे दिया रहा
Sasa roka deh.
हाँ
Chasha. Kalau udah ada.
चलो अपन खुद ही रखना है
Dari mati urara sermat. 1500 रुपये तिराला जाकर डे डिस्काउंट को 1500 तिमाला रहो इमरा नोट मात का चलो okay I am telling you what the mistake I was does. We have a damaged modulator. Just wait, I need to finish the customer work. and I just need to receive a money, and after that I'm telling you, and now I need to provide a fixed power supply. Why we face the difficulties? Because first I told you my bench power supply is not constant. Okay, so for increasing the voltages I increase my bench power supply, and after that when I decrease voltages, so the consumption power is low, and after that the input voltage is going high. And here is our modulator. So first we need to provide a constant voltages for this modulator. Okay, but we can this in this big empty PCB. Okay, now I need to just replace this modulator. This is the UC3843. This IC can provide you 99% duty cycle. It's mean if you connect the input power. I have again a call. Hello? Salam. Hey. اختار باي واحد رازيو. Mhm. 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 سهار پورې وای صبر وکړي چې غرمه راوخیږي که نه تاسو پسې هم د شپې ځئ مړه تاسو عجیبه کار کوئ شی د سولر دی او تاسو پسې ورځئ د شپې اوس زه درته څه ووایم بس د اسمان کې خو بره تیاره ده نه که په دې پسې چې ځې داسې کم سې کم د ماسپښین نه بعد په دې سیسټمونو پسې مه ځه چې نور نه وي مه ځه پسې اوس چې سولر وای سهاره پورې وای صبر وکړئ نو په غلط ټایم ځئ که نه په دې سیسټمونو چې همیشه ځي د نور په ټایم کې ځه په غرمو کې اوس بیټري لو ده نو بیټري لو ده که نه ته داسې کار وکړه چې سهار به پسې بیا لاړ شي په غرمو کې چې جومات کار له چې ځې غرمه به پکې شرط دی ورګس کې به هم داسې غرمه به پکې شرط دی چې څومره میاشت صبر کوي خلک روغ وایي غرمه به پکې شرط دی داسې شی چې کول غواړي که نه پی ایس ته دې جوړ دی Okay, sorry Parvet. First we install a UC3843, and now I have no anyone UC3843. This IC can provide you a 99% duty cycles if you provide a 15 volts. So after that you can receive a 14.9 volts. Okay, and now I am using UC3845, and this modulator giving us can give us 50% duty cycle. So if we provide a 15 volts, so we can get just 7.5 some voltages. Okay, now I'm just installing this modulator in this layer, and after that how you can create a fixed or constant voltages for this PWM modulator. I already installed this around 100 volt input. Okay, no any isolate a transformer. Okay, now I need to check this again. I am increasing the voltages again. Okay, Output voltages we receive again. Okay, now I am, oh, I there's a mistake again. I need to provide just around 14 volts, not more than. Okay, we are in the start again, so we can mistake. Okay, but we can fix. Okay, every solution, every problem related with this step DC to DC, step down, and DC to DC, step up converter. Okay, so now I need to install another PWM modulator. Now I need to look this meter, input meter 4.7. Okay, we are receiving, okay, 10 volts, yeah, 12 volts. Okay, how much voltage we can receive? Now this is the 50% duty cycle modulator. I'm increasing it. Okay, we have inductor, capacitor, so we can receive the output voltage is also constant with some resistors and one TL3 TL431. Okay, now I'm disconnecting this halogen bulb. Okay, you check 5.064, and when I connect 5.066, okay, it's the constant, and we need to work on this properly like this. And I have a powerful inductor for this to make a more powerful step down converter. And I have two pieces. First we need to create from this. This is a very powerful inductor. Okay, but this is the full schematics of this, but we have one thing not in this: current limitation. We can adjust our output voltages, but we cannot adjust our current limitation. For example, if you short your output, so we need to limit your output current. Okay, so in this we need to limit the output current. Okay, so I need to remove this thing, and first we need to create constant voltages for our PWM. And if now I provide a PWM for PWM fix constant voltages, so I need to add one voltage regulator like this. This is the D1047 voltage regulator. Okay, in this live stream I can fix the voltages for this, and I can increase this voltages around 45 volts. Okay, because now I have a 50 volts capacitor for input, and we need to install here capacitor for input voltages. And step by step, we need to work on this to guide you how you can create a PWM modulation. This is the first and difficult thing for pupils, okay, who are working on step up and step down converters. And this is the hidden trick to create a PWM, pulse wide modulation for this. This is the hidden thing, okay. This is the D1047, okay. And how we can fix our voltages with the help of this regulator. First of all, we need to have 12-volt Zener diode. Okay, I am removing from this old project, so we need to clean our this custom PCB. Okay, I am sharing you. After that, okay, this is, I think, the 12-volt Zener diode. So now I am just creating constant voltages for this PWM modulator. First I need to create like this. I am also first creating with this method, and after that we can design a PCB with AZADA and much more software we have for this. You can create a PWM circuit in this small area like this. Okay. Now we need to have a two 10 kilo ohm resistor like this, and we need to make a parallel connection. Okay, this is the temporary. And I am just checking about the viewer interest. The viewer interest. People are interested in this thing now or not. If the people are interested still in this converter, so I need to work on this in live stream, not uploaded video, to hide some things. Okay, and you know about, we lost 2 times my PWM modulator. Here we need to install one capacitor for output filter. Okay, now I need to connect wire or negative. Sorry for blue color. Now I not have a black for DC. It's okay. I need to provide a red for positive. And I need to connect this capacitor with output. Okay, this is the output. It's okay. Now I need to install for input positive. Sorry for bad wrong colors. Yeah, or input. Okay. Now I need to connect this with input. This is our input. First, I need to remove my from. Okay. After that, I need to connect this. Okay. Now we need to connect this with negative. First, I need to remove my prop. And I need to remove this negative. And here I need to install a solder. We need to add some solder. This is the SMPS basics. When you learn this basics, you can create all types of step down and step up converters and SMPS power supplies. Okay. Now I need to check. First, I need to disconnect this PWM modulator. Okay, I decrease my voltages and I need to disconnect from here. This is for the PWM modulator. Okay, now I disconnected this. So now we cannot receive any voltages because the PWM modulator was disconnected. And now I need to check our this constant voltage regulator. This is our negative and this is our input positive. Here we have a 15.4 volts and here 14. I think the Zener diode is 14 volt. Why? We have output 15. This means our Zener diode is 15 volt. What man? First I need to read this number. I can read. I think this is a 12 volt, so I need to connect this. And I think okay, now I need to check what's going on. Okay, this is the negative power, so I need to keep here. And this is our input 14.8. and this 11.6. It's enough. Now let's check the magic of this positive voltage regulator. I have provided a 50 volts. This is the input of this regulator. Okay, I need to set my meter. Okay, 50.9. And the output we have 11.6 constant. Okay, so now I can connect this with this first. Okay, I need to connect this PWM modulator positive. Okay, and now I need to check. This is our input voltages. Okay, 4.7. Okay, the bulb is glowing. Now I can boost. Okay, 25. Okay, we have a 51 input voltages, and we have constant voltages 5.1, and you can decrease and increase. Now I'm increasing. Okay, this bulb is 12 volt bike indicator bulb. Okay, I need to set here a little. This is not the LED bulb. Okay, this is the halogen bulb. You need to set this paper to don't disturbing you. Okay, and how the output voltage is constant, plus minus 1% or 2%. Okay, you can create for you. Okay, the schematics diagram I am sharing with you, and you need to just add more components in paralleling. Okay, this is just the basic rules, but one thing we don't have the current limitation, and we need to limit our current, and we can. Okay, but in this we need to work on current limitation on this big board. Okay, so if you know about this schematics, so you need to do a comment. Yes, so I can draw the full schematics of this, and you can create your own step down converter. Output voltages is constant, as you can see. Here we have 18.3 voltages, and now this voltage is decreasing. So if we have a 17.2 voltages, and now I am increasing. Okay, we have a constant voltages. So this is schematics of this, and you can adjust output voltages. If I need, I want a 5 voltages fixed constant 5 voltages, so I can decrease. Okay, Now I set on 5 volt. Now I am decreasing the voltages 4.9. Okay. 1 or 2% up down our output. Okay. Now if you want to draw the schematics, you can draw the schematics. But first I need to clean this PCB from every component. Okay. And one thing I was added soft output, like from 2.5 volt, 3 volt, 4, 4.5, 6, slowly, and I need to work again on this with some capacitor and some resistor just to start a DC motors for soft start. When you connect the step down converter and connect the DC motor, so they smoothly run. Okay. I can add this feature in this step down converter to provide you a soft start voltages. Okay, so this was my wish to create again this thing. And about, as you can see here, we have, and I need to provide how much voltages I can boost. 71, 86, 90, 92, 97.2 volt. We have an input and we have 5.12 volts output. Okay. It's okay. All fine. It's okay. Now I need to remove this thing, and after that I need to work on this permanent PCB. Okay, and I need to remove all these components again, and I need to build again and share with you every soldering. Okay, and every schematics. So I need to draw some schematics for you to make this PWM modulation, and you can adjust your frequency from this modulator. This is very simple. You need to get a white patch for this, but the viewers are not interested in this thing, so I need to close this topic. Okay, and see you with next topic. Take care. Bye. And I am publicly show this video, and I need to comment on this. So after that I need to create more project like step up and step down and isolate power supply. Bye.